Welcome friends. In this new video, we discuss about the Picard's method of successive approximation. Friend, this method is useful to solve the first order differential equations with initial conditions. So, Picard's method known as a Picard's method of successive approximation, and it is for first order differential equation dy by dx equal to f of x comma y at the point x equal to x0, y equal to y0. These are the initial points. This is a very simple method. In this method we have to integrate this between the point x0 to x. So whenever we integrate this, this will be the integration of y, and between the point y0 to y, and equal to integration of f of x comma y between the point x0 to x into dx. So integration of y, dy is y. So y between the point y0 to y, integration x0 to x f of x comma y into dx, and we get here y minus y0 equal to integration x0 to x f of x comma y into dx, and y equal to y0 plus integration x0 to x f of x comma y into dx. In this last step in this equation, so suppose that first approximation from obtained from the original equation is u1 of x. Substitute this u1 of x in equation 1 and call that as a second approximation and denote it as a u2 of x. So u2 of x equal to y0 plus integration x0 to x f of x comma y is u1 of x first approximation. So it will be converted into a function of x variable only, and we get this as a second approximation. How we have deduced the second approximation? By substitution in equation 1 u1 of x. What is u1 of x? u1 of x is nothing but an first approximation obtained from this differential equation. Similarly, to get the third approximation u3 of x, let us put it as y0 first term plus integration x0 to x f of x comma u2 of x, and you will get the third approximation. Likewise, to get the fourth approximation, put the u3 of x instead of u2 of x and integrate. So in this manner we apply the Picard's method to solve the differential equations. Thank you friend. Thank you for